communication satellites. She has played an important role in the Mars orbit mission, which is also known as Mangalyaan. She has worked on the launching of the satellite GSAT-12 and GSAT-10. She is the senior most female scientist at ISRO, having joined the space agency in 1982 and also the first woman to become a satellite project director at ISRO. Anuradha Ma'am is a distinguished scientist working as Director Sat Communication, who was early Indian GeoSat Program Director at ISRO Satellite Center. She worked in the area of geosynchronized satellites, which are crucial to telecommunication and data links. She has been a leading figure in several Indian space programs.
Anuradha Ma'am's role was very instrumental in developing and launching the ISRO communication satellite GSAT-12 into space from the Satish Dhawan Space Center on 15 July 2011. She supervised and headed the technical group of 20 engineers. As a part of an all-woman research team, together with Pramoda Hedke and Anuradha Prakash, she maneuvered the GSAT-12 into its final orbit from ISRO's Master Control Facility in Hassan. After working with GSAT-12, Anuradha Ma'am led the launch of a much bigger communication satellite, GSAT-10, in September 2012.
As a project director, she also oversaw the launching of GSAT-9, GSAT-17, and GSAT-18 communication satellites. She has also served as project manager, deputy project director, and associate project director for the Indian Remote Sensing and the Indian Regional Navigation Satellite System programs. Her specialty is satellite checkout system, which observe a satellite's performance once it's in a space.
For such tremendous and huge contribution towards our society, Anuradha Ma'am has been honored with the Space System Management Award in 2016 by Astronautical Society of India. She has been conferred upon as a Woman Achiever in Aerospace in 2019 by Aero India. She has also received Rajiv Gandhi Mahila Shakti Award in 2019 by AGRASRI, Tirupathi.
Anuradha Ma'am has also received the 2003 Space Gold Medal Award by Astronautical Society of India for the service in the field of space science, as well as 2012 ISRO Team Award for being team leader in the realization of GSAT-12 and many more. There's a lot to mention about Mrs. Anuradha T.K Ma'am. We are immensely honored by her gracious presence. So, without further ado, I now request Anuradha Ma'am to take this event forward by sharing her valuable knowledge with all of us.
Thank you. Namaste to all of you. On the outset, I would like to congratulate the students of Guru Govind Singh Ji Institute of Engineering and Technology and a very learned staff were there who have been encouraging the students. And congratulations on PRAGYAA events. PRAGYAA is a very beautiful name because that is something unique to humankind, the consciousness. So today I would like to talk to you about a little bit about space and about ISRO. In fact, both the topics are very vast and it needs more time. Since we have 1 hour with us, I'll try to give you a window that can be opened to these things so that your curiosity can be opened up, can be kindled, and you can get more into that, whoever is interested. And thank you for the wonderful introduction, but I would like to make a small correction. I did not directly participate in the Mission Mangal, not the movie, our Mission Mangal from ISRO, because as was told to you, I've been in the communication satellite programs, though in my initial time I spent some time in remote sensing and navigation too. But I have not worked on the Mars mission so far. But of course, it is our very proud program from ISRO. So with that, I would like to give you a small brief on space and what ISRO is doing for space. And let's just begin. Space is the fifth element of Panchabhutas. So all of you are aware. So the youngsters in my children's age, they were seeing the Captain Earth with 5 fingers, fists shown, So the power of water, power of wind, fire, and the earth itself. So the fifth element is the space. So these five elements were recognized very much, even in our culture, the Indian culture way back, and I'm sure even in the other cultures. So if you see that the human beings, as we started looking at these five major elements, recognize these five major elements, the first was fear, because each of them could create a havoc for the livelihood of the human beings. There could be earthquakes, there could be tsunamis and typhoons. Of course, the fire could destroy everything. It was so unknown what was the sky and what things. Suddenly there is water, there is lightning, the thunder. The fear started. Wherever there is a fear, it will be followed by trying to appease, giving a symbol of God to each of them and trying to appease this God so that they protect us. And slowly human mind, being so curious and extraordinary, started understanding each of these elements and started conquering too. Conquering means taking advantage of, making use of. In this, the last one to come was space. That's why even today, space is always an enigma. So what it contains, nobody fully understands, with so many decades of research also. So this always captures the interest. First of all, I would like to tell that I would like to give a homage to all even Indian scientists, even way back, Aryabhatta, Varahamihira, Brahmagupta. They were fantastic mathematicians and astronomy scientists, in fact, because they could predict the movement of these planets and they could predict what it was and try to comprehend how the universe was. In fact, it is very surprising. Way back 1500 BC itself, the Vedas, which are there, of course, the dates are always arguable, but no doubt it is millions of years back. There you see that people knew, the Vedas have already mentioned about the structure of the universe and how the solar system is, including the solar system. Even though in the medieval time we all forgot, the Vedas very clearly show that it says that the sun takes all the planets around him like a charioteer with his horse. There's a shloka to say that. The modern sages like Vikram Sarabhai, Satish Dhawan and U.R. Rao took us to the modern space world in India. First of all, what is this space? Technically speaking, anything, space, if you just hold your hands, this is a space between two hands. Everything is space. But when we are talking in this context, when we say space, we need to understand that it is not the simple English word space we are talking. Earth or any other planet, it has got several layers. If we take, for example, Earth itself, you have troposphere where, nearly 80%, 75 to 80% of our air is there. Stratosphere, mesosphere, you have read about all those things. But there is something which is defined. It is not a actual line of boundary, but a technically defined boundary called Karman Line. Karman Line is that where the aerodynamic principles will fail to lift the aircrafts because it is so rarefied. The atmosphere is so rarefied there. At around 100 kilometers, the usual aircrafts, the technology what we are using, it is extremely difficult to do in the normal process. So that is defined as an imaginary boundary line of 100 kilometers. And above that is defined legally as the space. I'm telling legally because it's very important that any space underneath, it will fall under the property of the nations. You can claim like this is my water boundary, this is my sky boundary, like that. So here the Karman line will define beyond that is space and it belongs to everyone. So let's understand the definition so that we can understand better. So, and our universe, I'm not talking just about the earth and what is beyond it, the observable universe, because what is universe today we cannot gauge at all. Lot of mathematical computations and lot of theoretical research can bring out many things, but still there is something called observable universe, which we can observe with even with our satellites and telescopes put in the sky, or even with the physical interpretations. There are 200 billion galaxies, and each galaxy with millions of stars, and dimensions are unimaginable. And this is expanding continuously. And there are so many amazing phenomena like black holes and, the radiations, what are they, the birth of stars, the death of stars. So many fantastic things are happening beyond comprehension. And man is trying to make a effort to understand where the man belongs to. So, why are we doing this? We all know it is very difficult and it is highly expensive quest to understand space. Still, what is it that is motivating human beings that they have to do this one? You have seen the allure of the sky and space millions, actually centuries before even the 20th century, maybe in the 17th, 16th century, there have been recorded, trials of how to fly like a bird. People have put balloons and they have tried to fly down from the tree or from the building. They have fallen down and they've, given up their lives. And of course, you all know 1902 is when the Wright brothers, they could demonstrate that with aerodynamic principles, they could take it. And it has gone so fast. It has moved so fast within a century where we are today. The aircrafts and the first satellite, 1957, after the airplanes became commercial sometime in 1910, imagine that within a short period of time, there was a satellite Sputnik by Russia in the space. And in the same year, they could send a dog Laika into the space to understand whether human beings can be there, what is there in the space, what we define as space. And not too far away, human beings went into space and landed on the moon, and crafts went beyond, solar system, exploring how many planets and really what are they made of? Are they like Earth? And not very far, 1997, first rover on the Mars, unimaginable. And India too, when we have started our own space programs, not as long behind as the other countries. In 2008, we could attempt to reach moon. And in 2013, even we could reach Mars with the capabilities what ISRO has developed.
Excuse me, ma'am.
Yeah.
Ma'am, sorry for interruption. Your PPT is not visible.
What do I do? You're not able to see the PPT?
No, ma'am, it's not
Ma'am,
visible.
present again.
Yeah?
Present again.
It is now there?
No, ma'am, you can present now. It's like there is an option below present now and you can present it from there.
I'm so sorry. Now you're able to see?
Yes, ma'am.
Tell me if you're seeing.
Yes, ma'am, it's visible.
Excellent. So I was just telling you about a wonderful thing that went on in a short period of time, visiting the space, and India is not far too behind. And very recently, you all might be reading about trying to put a helicopter on Mars, Ingenuity helicopter. I don't know how many of you are following up on that. Perseverance lander was there, and from there, a helicopter flew for a few minutes. Actually, the whole thing was an exercise to understand in the thin atmosphere. Like I told you, aerodynamic principles don't work when there is a very rarefied field. And Mars is one such very, very rare atmosphere. And it could be demonstrated that with certain technology, we can fly even over Mars. This is a fantastic, phenomenal growth in the way the understanding is growing about the space, and which we cannot directly see. But we have also understood that it's not easy. Space, as beautiful as it looks, with all wonderful twinkling stars in the sky, in reality, it is not like that. Extremely harsh environment. There are solar flares, geomagnetic storms, cosmic radiations. Van Allen belts have to be passed if you have to take a satellite through that, which are all full of charged particles. And there is a disturbance, there is a radiation. Anything which is electronic or even the mechanical materials, they can completely get destroyed in such an atmosphere. Added to that, we all know there is a hard vacuum. Vacuum has its own perils for any system you send. Any material cannot withstand it. There will be a structural defects when you get into such hard vacuum when you go into it. And extreme temperature cycles. For example, our own satellites, when you see they can move anywhere, minus 150 to plus 150 systems will be, the outer elements can be seen. So you have to do very elaborate thermal designs, even to go and see there what it is. And of course, the stability itself. There are gravitational pulls from sun, moon. You have to live with it. And there is a lot of space debris, not necessarily from what human beings are creating. There is space debris, lot of meteorite particles which are moving at extraordinary speeds. They can come and hit. And how lovely. We call Earth as the Goldilocks region, It is so beautifully protected. We could not see all this harshness outside the Earth, what is there. And as I was already explaining, any instrument you try to put in the space, this harsh element is bound to, pull it away and break it down. Radiations and even, impact will spoil the mirrors. ISS also, the mirrors are specially made of certain material, scratch-proof materials, because they're continuously getting bombarded by the particles. So a lot of technology has gone over the century to build these kind of things. Then why space? Aren't we happy in our own world? We can very nicely sit at home and enjoy. But space is required because of the scientific adventurous nature human beings have. And at the same time, they have found out enormous number of applications which can be brought from the space. And it has opened up large number of services and business, and a lot of applications have come up. Today, the space applications are so ubiquitous. You will not realize that every day-to-day life, everywhere you are using the space because of the technologies, and it has become a business model. So both these things, whether it is scientific adventures or the services and business, all things depend upon the economics and the market. If you see the fast development in the space, understanding what we had in the middle of the 20th century, there was a lull in between because countries were not ready to spend money. So somebody has to invest money, then only it is possible. So that investment came as a competition during the Cold War time and, all the technological development that went on. So now again, there is a renewed interest because of our own fragile environment. It is imperative today that we have to look out and whether there is a possibility that we can save the humankind, we can save any kind of life on Earth and then put it out somewhere else. Who knows? That's the way we came on Earth too, from some other planet, right? So what is the specific advantage the space gives us? When you put an instrument in space, some advantages are there. For example, the coverage. If you stand on the roof of your house, you can see a larger area. If you go on a hillock, you can see much larger whole village or the district you can see. And if you go into the space, large coverage areas are there, which is limited only by the curvature of the Earth and the height where you are going. So way back it was established, by this, this writer, scientific writer, who showed that just putting 3 satellites at 36,000 kilometers above, you can cover the whole Earth. Okay, so this viewability, ability to see things, is one big advantage in the space. And once you put an instrument there, it is a uniform service. It doesn't care whether it is a village or a city, or whether it is a hilly area, valley. It doesn't care. So you get a uniform kind of services everywhere. And there is a continuous availability day and night for the human beings. You get fantastic services from there. And there are no epidemics, luckily, no lockdowns there, and satellites will be working all the time. And at the same time, as I told, day and night monitoring. So, for example, if you want to go through an aircraft and see, or you put a radar on the top and try to see with a visible light impingement, so it is not possible in the night times. Whereas there are techniques to, even achieve those things from the satellites. And when it comes to the scientific aspirations, if you want to look beyond, look at the great lens and then see what is this universe made of, Earth is not a suitable place, because it is so polluted atmosphere. You get totally misled by the informations that you get. And lack of atmosphere is a great advantage there. And you can easily maintain satellites. Satellites very happily live for 15 years, 20 years. By the time technology itself will change, you want to replace it yourself with better instruments. So there is a huge advantage. And what are the applications that brought in? We can have a look at it. So I think I already told you all these things, advantages. Once again, I don't want to go into that. Then let us see now, with these advantages, what ISRO has made. How are we utilizing the space? And today, ISRO has made India proud that we are on the world map of spacefaring nations. Not many nations are there. Definitely not many nations with our economical background are able to set their flag high in the space, and India could do that. How did we do? I would like to tell that, first of all the credit goes to our, visionary, who could think that Vikram Sarabhai, who told us that we are not doing a rat race with anyone. Not like America and Russia went on a race that you have put a man, you have put a dog, I'll put a man, you put a man in the space, I'll put man on the moon. No, that kind of competition. Here, we had a very firm rooting that we will bring the applications of the space to the common man for the betterment of the human. So in that process, we did not have a competition with them, and I'm sure we would have lost on them, but here we became leaders in our own way. Today, for all countries, the Asia countries around us, and the third world countries, we are a leader today, and who have taken the space-based application to the normal society where we live in. I'll just tell you what we did. First of all, it was the determination. You all might have seen these pictures, So whatever humble facilities we had, humble infrastructure we had, we went ahead and did. And even the biggest scientists, they did not mind dirtying their hands, working, hard work and determination. That's what took ISRO forward. So what were the major domains of space application ISRO thought of? Remote sensing, communication, meteorology, very, very important for India, and navigation. Navigation applications, like all of you are aware of GPS. So I'll tell you about the Indian GPS too. An ocean of applications came by mixing and matching communication and remote sensing, communication and meteorology, communication and navigation, remote sensing and navigation. So thousands of applications have come out today, and business in India is thriving with these business applications. So ISRO started on a humble roots. Whatever you take, whether you take communication, we put a very small experiment. Somebody could take it free on their rocket. That was called Apple, Ariane Passenger Payload Experiment. We started way back in 70s. Then today, where we are, today we are second to none in bringing the best technology in communication and connecting the rural India, connecting every nook and corner. We're able to do that. And remote sensing too, we started with small experiments because we did not have great investments to do. So we tried out small things, and today, one of the leaders in remote sensing today for the civilian applications. Of course, remote sensing has gone to a great notch ahead for the military applications elsewhere, but for the civilian applications, we stand first. And navigation and explorations also, we did not stop with that. We had our own bounty of explorations. On the same time, on the other side, the Indian launchers went on. So, of course, that is a technology which is not easily available on platter to any country, because the launchers have a dual edge. It can become a weapon, or it can become a rocket for launching a satellite. So nobody gives you. There was a lot of hard work, toiling, and friendships, associations. And finally, today we are having our own cryo engine. And we are also, poised today to take the human space program further. So that is the amount of growth that has happened over 4 decades of ISRO, 4 to 5 decades. Let us just start the applications because we don't have much time. Quickly, I'll go on that. So as I told that the satellites serve as a better tools for remote sensing, and we have passive and active imaging. When you say passive imaging, it means like a camera. What you do, you take a click and you get a digital data at the back end, which you can transport it to any computer or something. Very similar to that, we have electro-optical systems on the satellite, which are highly evolved compared to these computer cameras. And, you can image the entire globe pass after pass after pass, and they're in multispectral. For example, when you see a camera and take a picture, it is only in the visible light range. But there is an enormous amount of information beyond the visible too. Infrared to ultraviolet to X-rays, and thermal. All this information or extraordinary amount of data, and that we are able to do with these electro-optical systems and multi-temporal images. So you can continuously keep imaging the globe so that the smallest changes, how these platforms are moving, how these icebergs are moving, how the mountains, whether their height is increased, decreased, all these things you can study. And you get the 3D and radial resolution. Radial, when I say, basically the radiation from the object is sensed by the satellite cameras and interpretation happens. So that sensing of the radiation, how fine it is, that is called radial resolution. Spatial resolution means how small you can see. In fact, if I see our remote sensing data of my house, I can see so clearly my house, top roof, everything. The fantastic images are there. And earth monitoring, not necessarily for the city, earth monitoring, ocean, mountains, forestry, and ecology, for ecology, and the weather monitoring, clouds, winds, how they're going. And for the security, national security, these remote sensing satellites have become very important because of that, they are also today called the fourth frontier. We have Army, we have Navy, and we have Air Force. Space is the fourth frontier. And you can do remote sensing, apply the same thing for other planets and understand other planets too, which we have been doing. We also did on Mars, the same thing. Just I want to show you these resolutions, how it matters. See, the same area, which can be taken on 1 kilometer resolution, how it looks. As the resolutions improve, and radiometric, spectral, and spatial. For example, monochromatic, if you see your top, the second one, monochromatic, it does not have many bands, many colors it is not seeing. It will be highly, spatial resolution is very good in that. But you don't get the features of colors. But you can take 2 photographs, one or the other, superimpose and get fantastic ones. Today we are poised for sub-meter resolution, and we can get such images with our own satellites. And what ISRO has done in this one, you may say whatever I told is all theory and everybody will be doing. But ISRO, when we started way back in 1979, to, you see now, 2020, the number of satellites, the fleet of satellites have increased enormously, decade after decade. And we have gone to very high technologies like hyperspectral imaging, all-weather imaging, submeters, and it is it's a very proud moment to say that remote sensing has contributed for every department in Government of India. They have utilized this data, whether it is town planning or connecting the rivers or whatever. And I'll tell you about those also. 40 remote sensing satellites we have done with intricate instruments, and we brought in thematic. See, continuously, resource sats, ocean, why you need thematic fleet of satellites? Because these remote sensing satellites are somewhere between 600 to 1,000 kilometers above the earth, and they'll be moving. They are not available continuously. So when the one satellite goes away, bring in the other one, so that you get less gap. The temporal gaps you can give less, so that you can monitor continuously. Today in the sky, above India, not above India, it's going all around the globe. 13 satellites are there, and they are giving services even to the other countries. So it is one big, international cooperation thing that India is helping others, and we take from them. So when you have equal footage, people respect you. You cannot be always on the receiving end. That was the thing. Some examples I want to give you. For example, the tribal dominated districts, 168 districts, we brought in the water body identification using remote sensing. Fantastic program. With that, there was that, aquaculture, that fisheries which were brought in, and the tribal people, they could be included in the mainstream with certain income, and their quality of life improved and health improved. And these are the things, it is our dream that we take India as a whole together. And if you look at the fishing zone advisories, there are, I think, some 7 million fishermen in the 7,500 kilometer of coastal Indian coastal border. And today, their life has improved so much. Before these facilities were provided, they get advisories on their handheld instruments with regard to where the fish is available. It means that their time for catching is reduced, and they are able to spend more time with the families, and their income has improved, the quality of life has improved. And in addition to that, they are also given warnings. As I told, mix and match, we have information with our own navigation data that whether they are crossing the boundaries, whether they are safe or not. And similarly, meteorology application, how is the weather that is happening, and whether they should get alerts and come back. So these are all in vogue today. Everywhere it is being used. And there was another interesting thing on the portable groundwater resource, wherein so many states used it, and they did bore wells for common usage everywhere. 85 to 90% of success was seen when they took the remote sensing data. Remote sensing data not only sees on the surface of the earth, it can see even underneath. There are radiations, as I told, which we can't see with our eyes. Radiations which give information. The radiation which tells there is underground water. There is a radiation that tells there is a metal here. These kind of things. And disaster warnings. You have been hearing about disaster warning, the role in management. The moment you have the warning, you can help them. And once the disaster has happened, and assessing what is the destruction and how to do the management, where the money has to go, and where the people have to go and do the help. You cannot run helter and shelter. You have to go and hit at the target. And agriculture is one great thing that is going on. If you see the agriculture, I think nearly 4 crore farmers who get on their handheld advisories to them. What is every crop we can identify, because the different radiations they come, and the crop growth, how it is going, we can monitor. And also it is told that whether there is a disease for the agriculture somewhere, there is a disease for the plantation, and early actions can be taken. And it helps a lot for the farmers to do these things. And also there are 2 times we do the, Kharif, and there are 2 times we do monsoon time and Kharif time we do the agriculture, at which time where is the water and whether pulses can be grown again. The income of the farmers increase with that. Insurance companies are using this data quite a lot because, insurance premiums depend upon success or failure. And the town planning is something very big that has gone, town and villages, and very nice assessment of the properties have been given, and therefore all districts, they have their own decentralized planning. They can do the planning which is appropriate for their district, for their gram panchayat level. They are able to do the asset mapping, and a lot of revenue is also generated because of which, because of the fact that now the properties are cleanly demarked and there are digital data available. Nobody can tell, I don't know. And town planning, river linking, all these things, as I told, we call them as digital elevation models. So entire area, very useful remote sensing data. Most of it will not change, and whatever change is happening, we'll come to know. The forest fires, you come to know, and how to quickly quench those fires. These are all. There are so many examples. I just want to tell you a few of them. Now we'll come to the communication. Communication too, as I told, grew from our humble beginning. What you saw on the bullock cart was our first communication satellite, Apple, which was there, and today we have 43 communication satellites made with state-of-the-art technology, and today there are huge number of business are running. And I was in charge of the SATCOM program applications also. I must tell you that so many TV channels, telecoms, telemedicine, all these are supported so well by our communication satellites today. And communication happens in the bands, S band, C band, KU band, Ka band, and all that. So these higher bands, when we go, the technology is complex. Today we have demonstrated we can do in the V band, Q band, and the optical bands. That means a large bandwidth you can get. There is a huge advantage the way we have brought in exotic kind of antenna designs have been made indigenous. We have developed them, and India is a very vast country and very difficult terrains, and our demography is also so diversified. So these communication satellites, in terms of broadcasting and DTH services and news gathering, you can just see some examples here. Entertainment is a big business. As you see that nearly 900 channels are there today. Why? So many languages, so many regions, and that is what big business, everybody is getting up-to-date information. And the commerce and business is entirely based. Your stock exchanges, you go to your ATM and look on the top, there you will see an antenna. That antenna is actually connecting to your main branch, whether you're in Timbuktu or wherever, you can still draw money and then take it. That is because of the communication links provided. Whether you're on the aircraft, in-flight connectivity is provided. Whether you're on the ship, you have the connectivity everywhere. And societal aids, fantastic. As you see, the pictures here, I don't have time to tell you each and every one of them. The weather monitoring and communication. Today, you don't see any life being, lost because of these kind of natural disasters, because there are early warnings. Of course, disaster itself you cannot help, right? So it has to, it will come. It is not in our hand. But damage, how much we can avoid, it is in our hands. So similarly, search and rescue operations. There is a continuous aid for any fisherman or hiker or somebody who is lost in the forest. If they just press the button, their locations will be identified and immediately help will go to them. We are also part of the international forums in this one, and a lot of lives have been saved. And I always call, telemedicine and tele-education as our, the best programs what we had. If you see telemedicine, demonstrations were made by ISRO, and many states have taken forward. ISRO cannot run every government, right? So governments have taken this forward. Telemedicine, we connected 386 hospitals and 16 mobile hospitals. and 50 super specialty hospitals and various districts in rural areas were connected. The mobile hospitals could go to the homes and collect the vitals, connect it to the nearby hospitals, and the specialists would advise them. And the villagers and these remote area people, they did not have to, move unnecessarily just because of the panic. And especially this is used by Indian Army in the difficult terrains. This telemedicine is doing a great job there. And tele-education was one fantastic application that went on. Education is most important for the society next to the health. And tele-education also we demonstrated with various networks, and nearly 55,000-60,000 classrooms were connected, and those demonstrations were taken forward. Many programs we started. Some KEDA communication project, it went on later on as a Central Institute of Education and Technology. And you're all aware of IGNU, right? Indira Gandhi National Open University. That was initiated as a Jabua development program in communication for the tele-education. So these are all taken forward further by this one, and we keep giving them the capacity as and when they want, the satellite capacity as they need. And defense is another thing, as I told, it's the fourth frontier today, and it is also, I always call as mother of inventions. Wherever defense is involved, highest technology comes in. There was World War, lot of technology came in. There was Cold War, lot of technology came in. So defense, promotes a lot of technology that happens, and for all their communication and control, information gathering, surveillance, reconnaissance, all these things use our communication effectively. And lately, our Honorable Prime Minister, he started Digital India program, and to connect entire India and make it digital. In that, ISRO is playing a big role. We are able to connect 6,500 unreachable gram panchayats. Of course, nowadays there is a lot of terrestrial links also, but terrestrial links lying to unreachable areas is impossible. Satellite is the only solution there. So already our beautiful satellites, they are working there. GSAT 11, 19, 29, they are all providing this kind of communication, Andaman, Nicobar, and in fact, we were much earlier than the ground infrastructure which was developed by the respective departments. Satellites were made ready. They didn't have to wait for the satellite. So that is how the communication satellite has gone. And just briefly, I want to tell you about the navigation. So ISRO did not fall behind in the navigation too. You're all aware of GPS, Global Positioning System, which is an American system. So similarly, there are systems by Russia, GLONASS, and there is a system in Europe, and there is a system we do in China, and Japan also has brought in similar to what we have. What we brought in again was very unique. We did not want a global thing because we want to bring in the application to India and Indian region. So we brought in with minimal number of satellite configuration, just, 7 satellites put in the orbit, and we are able to give equivalent to GPS kind of services to India and 1,500 kilometers all around us. Why did we have to do it? Anyway, GPS was there. You must know that even the advanced countries like Europe, Russia, and China, why are they bringing Japan? Why are they bringing their own navigation system? Navigation system is one of the important factors for the defense too. Okay, and in times of necessity, a country which has these satellites can create disturbance, and it has been seen also that misinterpreting data can reach the users if you're not an ally. Right? So every country which is interested in having its self-reliance today is going for the navigation too to be its national program. And ISRO was very successful in bringing these satellites. Initially, we called them as IRNSS, Indian Regional Navigation Satellite System Constellation. And that was named by Honorable Prime Minister as NAVIC. So beautifully, name was given. NAVIC means, which can guide you through. So that was the thing. And we also have another program using the GPS itself. GPS data is not very accurate for those who are not meant to receive it. There are several types of signals that come from GPS for common use and for special users. So we have brought in space-based augmentation system, wherein we have set up very references and uplink to our own satellite, the GPS information, which will make it accurate and give it back. Same GPS receiver can have the Gagan also. We call it as Gagan, GPS-aided geo-augmented navigation. So this system is also running in parallel. But today we have entirely independent Navig system with us. So these are some of the major lines of applications I told you. But any scientific organization has its aspirations towards research and trying to find out the curiosity. It has to be satisfied. Our first step beyond Earth was to Chandrayaan, and Chandrayaan instruments. There was one moon impact probe with the national flag on it, which fell near the crater, which gave the indications that there is a possibility of ice water in the craters where there is no sunlight. And moon was reachable. That was a great thing. The whole mission planning, how to go beyond. It was first time we were doing, and we were successful, and we could go there. And it also hosted international payloads on it, So what it means India got a stand that yes, they can be our partners. I can rely on them, that I can depend on them, that I can put my instrument and I can take India on mine. So you're at par. That is a kind of advantage. And also it just exploded the scientific aspirations in the minds of common man quite a lot. And it was not a very long-lived mission, but we learned a lot in Chandrayaan-1. How is it to go beyond influence of Earth? Then further to Mars we went. Mars was a much more complicated mission, because even the communication, it will take 25 minutes for it to reach there and get an answer back from the satellite because of the distance, right? So, and going there itself, it's a rendezvous, a typical rendezvous problem. Mars was coming from somewhere else and Earth was going somewhere else. You had to wait at the right time that you inject your satellite and it should go there and get into the influence of Mars. So that was precisely done. And we learned a lot about how to make the things autonomous, because you are not able to control with 24 minutes up, 24 minutes delay. It's not possible. And management of the thermal system, some lessons learned from Chandrayaan-1. So the thermal understanding was much, much better. And we had highly, advanced telemetry and telecommand systems, and the propulsion system, which was kept off for a long duration after several months in the harsh environment. Again, it fired, and it was a great thing, taking care of those things that it should come on its own at the right time. It worked so well. And power design, and you don't get the same amount of solar energy as you get near the Earth. As you go far away, the sun's energy also reduces. So we had to make very special designs, very efficient systems. And we went again to moon, we planned that lander and rover also should work. Unfortunately, we lost the lander, and of course the rover we lost. But very soon we are going to visit again, and we have learned what went wrong, and we are going to do that. Okay, so that was one thing very nice. And I don't know how many of you know, engineering students, all of you should be reading about all these things. We have our own observatory in the sky called AstroSat. It is so unique that this small satellite, it is able to capture the entire range of the X-rays and UV also, and near UV, ultraviolet rays and UV. So why is it important? There are a lot of phenomenon that is happening in space, as I told. Scientists all over are, very restlessly waiting to see these things, to understand universe better. And this small satellite which went could detect one very, very old galaxy, which was, we could see that, and scientists have understood a lot how galaxies get formed. I'm not that kind of scientist. So we only make the satellite. I could make the satellite to the specifications, and the instruments have given such beautiful information. I understand from the scientists that they are able to do a lot of analysis and go further on that. And we have one more very interesting program coming, and that is called Aditya, to study sun. Interestingly, let alone universe, in our own solar system, how much we understand sun? Not much, So there are so many curious things that is happening on the sun. Why it behaves like that, we don't know. And we need to study that, and we can't do that from our own atmosphere. And that is why whenever there is a solar eclipse, people rush to the telescopes and try to study, because you can even see that because of those studies, you could see that even the light can bend because of the gravitation. Because of those studies, there is a lot more to be done on those things. So we are putting one small satellite called Aditya. Aditya means sun. So sun study it is going to do, and we are going to put it at a Lagrange point, 1.5 1,000 kilometers there in the space, and there it is going to sit. You know what a Lagrange point is? Wherever in space there are two bodies, there are 5 locations which can be identified where the pull, because of centripetal force and the gravitational force, all these forces, they have certain final impact that there is a stability at that point. L1 is 1 point, Lagrange point 1. A French scientist, he discovered these points, Lagrange. So there we are trying to put our satellites, and it is not a single point actually. So it will be a region. A satellite will be in that region, keep studying the sun, and it will try to, simulate the eclipse condition with its own instruments and study what happens and give back the data to Earth. So this is a very complex maneuver, how to keep the satellite not in a small box, but in quite a big area. It will be in a, it is a haze there. It will be there in that area, and it works on that. Of course, you all must be reading about Gaganyaan. That is our next, flagship program, what we have. Though all of you know that sometime in 2007 or so, we got a official clearance for going ahead with Gaganyaan, a huge project with 10,000 crore financing, budgeting, which is required. But our experiments had started long back. So we started doing way back all this readiness, and astronaut suit was made sometime early 2000s. We had done our astronaut suit, and we also did a lot of tests. Like we had in 2007 one space capsule recovery experiment, SRE. That was so fantastic, because that was when the material technology, when you re-enter, it can burn everything. Even the big meteorites, they burn up in the atmosphere. So you have to have special compounds and materials, ceramics, which have to be used, and we got a hold on that. And how to re-enter precisely and how to recapture. And subsequently, we did the crew module. The crew module was also recovered. We flew it on our experimental Mark III at that time, and then we recovered it. Even the parachute designs and pad abort test. In case there is a disaster, the astronauts have to leave the pad and come out. So that test was successfully completed. And we have made a humanoid called Vyoma Mitra, because initially in our first couple of flights, we are not going to put the human beings. So we have a robo and artificial intelligence, and which will gather information and pass it on, and in the crew module, it is going to sit. So this Vyoma Mitra will be sitting, and like human beings, it is done as much as possible, artificial intelligence. You might have read about it. So these are a lot of developments which have gone on these fronts too, other than the societal applications, as I told in the beginning, how we have been doing. So this is what we stand at today. So from the foreign countries, we have launched 342 satellites. And so far, these numbers speak that how many satellite missions, how many launch vehicle missions. But today, our international cooperation is, is at a very nice platform today. And in the rocketry, we cannot put a 10-ton satellite today, but we are going to do very soon. Today, our Mark III is capable of taking up to 4 tons. And most of the solutions we should bring with that, with better, even propulsion for the satellites, we should be able to make satellites smaller and take it up. So from the humble beginning in 1963 to today, India is recognized all over the world as a spacefaring nation. And you have also heard about our record, which was recently beaten, I think, by China, that 104 satellites in a single flight, we could take it. So these are some of the records nobody could imagine that India could do. It's all because of the the good visionaries we had, good leaders we had, and the hard work that went through this, and we were able to do. So way long back when we launched the first satellite, Aryabhatta, that was there on 2 rupee. Now our value has increased 1,000 times, right? Mangalyaan is on 2,000 rupee note too. So it's a sense of pride and joy for not only us, for every Indian, that we are able to achieve this in space today. And way back, Socrates, as he told, man must rise above us to the top of the atmosphere and beyond. Then only he will fully understand the world. And today we can add, he will understand the world and also appreciate what a rare earth it is, and what a rare opportunity we have, that earth has given such lovely life forms and plants, ocean, so beautiful. We can understand only when we go beyond. And that's what every astronaut has told. When he goes out, he sees. Rakesh Sharma also told, no? When India, how it looks, Indira Gandhi asks him, and he says, "Sare jahan se acha dikh raha hai," he says. So this is what I wanted to convey you fast, so that I can just ignite your minds with a little bit about what is space and what is ISRO doing. And I'm sure most of you will take interest and pursue. And today ISRO is also opened up to the private industries, because everybody cannot enter ISRO, because ISRO cannot have so many employees. It's a government organization, but you can work on space through many Indian private companies. Government has opened up today that ISRO will enable all these private industries, even use students. I know some of the students who made very good in bringing very small propulsion systems, small sensors. They're all working, and they're making small rockets, small satellites. But I'm sure with government's help and finance, they can do as good as anybody else, and they'll come forward. And I hope to see that from your college too one day. Thank you very much.
Thank you so much.
If I know answers, I can answer you. I cannot claim I know everything because it's so vast. So I would like you to ask questions irrespective of whether I can answer you or not. So that would be great. I hope I could keep up the time and you could do that.
Hello, ma'am. The first question is from Mr. Saurabh. He says, what do you think about the new space policy 2020? I mean, what kind of help and changes will it bring in Indian private companies and ISRO?
Yeah, in fact, that's what I was trying to touch upon in my final slide when I was telling you. So this is exactly what ISRO wants, because we want to look forward. We want to bring new, innovations and new discoveries and new technologies. We have to keep bringing. And today, what has happened? ISRO introduced a lot of applications. ISRO demonstrated a lot of applications, and ISRO is running many applications, even DT heads and all, the allocation of the band and making the satellites for these commercial applications and all that. We have to get ourselves free because our manpower is not increasing, right? So we have to concentrate more on the research. So now ISRO is really opening up for the private companies that you please take up all these satellites, which gives money, which means business. Please do it. ISRO is not for doing business. ISRO is doing for research. So though we had to do all these years because I suppose the private industries were not ready, but today government is giving a lot of support and they should be able to do. And we are there to handhold, we are there to guide, and in fact, a lot of structure is also defined today, how you can start and how you can get the help and what are the permissions you have to do. At the same time, you cannot be causing a kind of a destruction also, right? So you cannot just put a satellite and what is already there, you cannot go and hit it. So there are certain norms, regulations you need to follow. All those things are, controlled by some government bodies, and they'll help you doing those things, whoever wants to open. It is totally open today, whether navigation applications or remote sensing or communication, please go ahead. And that's what we are telling private industries, because government cannot put money on business deals, and business people have to do that, right? That's the essence of space policy.
Ma'am, I've got another question from Samradni.
Yeah.
Can you tell us about new upcoming plans of ISRO?
Yeah, some of them I touched upon. The most important thing is, of course, Gaganyaan, which is there. And we have our program for the Sun Study Aditya. And we have already laid out chart for Venus mission, and even for the exoplanets, we have missions. And we want to concentrate our energy on those explorations now. And applications are well established. And now it will be hopefully taken up by commercial bodies, and we have further explorations in mind, definitely. And we are also continuously improving upon even the propulsion system, for example. Today, what is 6,000 kg satellite, you can achieve in 3,000 kgs. That means you can, the launch cost will reduce, and you can use your own rocket to go up. That is called electric propulsion system. A lot of research is going on that, and all these kind of system improvements, advanced technologies. We have a whole list of those things to be carried out by us. We want to do those things. And mission wise, what you can easily understand, we want to go to other planets, and already things are there in the anvil. They are getting ready. They are going to happen.
So, ma'am, there is one more question. Is it possible for the black hole to eat an entire galaxy or Earth?
See, black holes are something which people are doing a lot of, studies and all. Black holes have enormous gravity, and they can, absorb, and even the light, it cannot give out. So much gravity is there. So, yeah, black holes can take material into them. Galaxies also, what is galaxy? I mean, it is made of material. And if there is a huge black hole nearby to it, and it keeps on expanding by eating everything, it can do. But at the same time, somewhere else, some new galaxies are getting formed. That is the way the universe is running.
Excuse me.
Please.
Can I ask a question?
Sure.
Actually, ma'am, my question is maybe off topic. The question may be off topic, but actually, I had seen a movie named as Interstellar. And in that
I also saw that movie.
Yeah, directed by Christopher Nolan. So in that movie, they have shown that the astronauts from India, they go to another, they find another planet, which for future, for goodness of people in India. And
is it like that? I think I've forgotten the movie. Okay, go ahead.
Yeah. So what happens is that when he travels on that planet, the time is very fast over there. So for every 1 hour, there are like 12 years or something years passed away in India. Not in India, in the world.
On Earth.
Something like that.
Yeah.
So like, is it really possible? Like, is there any...
You know what? It is a concept from theory of relativity. And yeah, that concept they have tried to picturize and make it happen. But to tell you frankly, I have also not studied much. But theory of relativity, Einstein's theory of relativity, it touches upon that the time is not constant. So time also changes as it goes. That is a concept. I have not done much study on that. I only know such a thing exists.
Yeah, ma'am. And just last question, what are your views on parallel universe? What are
Parallel
your
universe.
views? Yeah, is there any chance of having a parallel universe?
See, actually, multiverse, they call it as
Yeah,
multiverse, right? So these are all some theories which are there, and no one knows. Why me? I am nobody. That way, actually, no one really knows whether there can be a multiverse. No one knows what was there before Big Bang theory. Before the Big Bang happened, right? So,
yeah,
Big Bang is established that it happened because of many scientific studies and some demonstrations. But where was time? Where was space before that? Nobody knows. So, universe itself we have not understood. Multiverse definitely no one has understood. These are all some theories,
yeah,
and who knows, one day we get a better understanding. So many things what writers imagined long back are all coming true, right?
yeah. That's
So
true.
yeah, I mean, who knows? It can happen, and more importantly, it's there was also one more word, doppelganger, or what is the thing? There for everybody there is somebody else in the other universe, exactly like that and all that. So these are all some kind of theories, and there is nothing concrete about it. And there are no scientific proofs which are very substantial in nature to say all those things, but
Okay.
it definitely motivates you to learn more and read more and try to understand more, and in your lifetime somehow contribute more towards understanding
Yes.
that much I can say.
Thanks a lot, ma'am. It was really an awesome session. And I would like to just ask you, I would like to just tell you something that I'm from Kusrowadia Institute of Technology, Pune. And we also have Institute of Engineers, India. So IEI, so we also arranges such guest lectures, etc. So we would also like to keep your session in our college. So is it any? How can we connect you? Can you just give some idea?
Yeah, now my dear friend Sakshi has all my details. You can contact me, and
Okay,
if the timing suits, and we can do that sometime
okay, ma'am.
definitely.
Ma'am, thanks a lot. It was really an awesome session.
Thank you
Thanks a
so
lot.
much. It was wonderful, getting in touch remotely. And all of you take care. You're all wise youngsters. Please stay safe in the pandemic time.
Yes, ma'am. Thank you.
Thank you. Thank you very much.
Thank you. Thank you so much.
Thank you so much, ma'am. This has been a remarkable and very nice session. We are so grateful for you for this session. So now I would like to invite the technical secretary of our institute to propose the vote of thanks.
Thank you.
Hi, uh, good evening, everyone. I feel very privileged to propose a vote of thanks on this auspicious occasion. Ma'am, actually, it was a great lecture by you. So I'm just thankful to you for giving us your important and valuable time and delivering such important talk. I am very thankful to our director, sir, Mr. Y.V. Joshi, sir, our Dean Arun Patil sir, and I am also thankful to all faculties of our institute for such a great support. I would like to thank whole viewers of this session for attending this lecture, and I'm also thankful to whole team for arranging such lecture. I'm also thankful to all the viewers who are viewing this session, and I'm just thankful to our faculties and whole students who are constantly watching. Thank you, ma'am, for this wonderful session.
Thank you. Thank you. I enjoyed it too.
Thank you. Thank you. We also enjoyed it.
All the best for all of you. Thank you so much.
Thank you. Thank you.
So can I log out now?
Ma'am. Yes, ma'am.
सब लोग कैम ऑन करो ना.
आपने किधर से बुलाए थे आज लोग जितने सारे?